In this question, we're going to do a potential difference or voltage problem. And in this problem, it says determine the potential 2.5 millimeters from a negative plate of a pair of parallel plates separated by 20 millimeters. And these two plates are connected to a 24-volt battery. Okay, just to help you visualize it, you can imagine that we've taken a 24-volt battery and two plates separated by a slight distance. These two plates could be made of metal. They could be like two aluminum sheets. And then you just connect these up to the individual plates. And what you'll end up with is, based on the polarity of the battery here, you'll get positive charges on this side and negative on this plate. Now, I'd like to do a different diagram for you just while we're going to analyze it, but I just wanted to show you this kind of in 3D to help you visualize it. So with this diagram, it's like looking at it from a side view, but I think it's just easier to work with in this case. And what we're looking at here is we have a positive plate and a negative plate. It doesn't matter which plate you have as the positive and which is the negative, as long as they're two oppositely charged plates separated by a distance. What I'm going to do here, with 24 volts, I'm going to designate this right here as V equals 0 volts. And that would mean that this V is 24 volt. It's at a higher potential. Okay, so I've set the bottom plate at 0 volts. The positive plate, which is always at a higher voltage, is at the 24 volts. And the difference between them is 20 millimeters. And we'd like to find the potential 2.5 millimeters from the negative plate. I'm going to call it D prime, just to show that it's a different distance. It's going to be at 2.5 millimeters. And we'd like to know what the voltage is right there. So there are two ways to solve this problem, really. I'm going to show you one way that's the more sort of complicated way, but it does use the equations. And that way is, we know that the change of voltage is the magnitude of the electric field times magnitude of the distance. And so one of the things we can do first is find the electric field magnitude. So we know that it's 24 volts, and this is 20 millimeters, so it's going to be 0.020 meters. This is going to give you an electric field of 1200 newtons per coulomb, or 1200 volts per meter. What we can do then is, the electric field between these two plates is constant. So I've just quickly sketched it in there on the diagram to show the electric field points from high voltage to low voltage, from the positive charge to the negative charge region. This electric field magnitude is a constant, and so what we can use it for now is, I'm going to call this delta V prime, which is going to be the one at 2.5 millimeters. This will be magnitude of the electric field times D prime. So this is going to be 1200 volts per meter, and the distance D prime is 2.5 millimeters, or 0.0025 meters, and that's going to give us a voltage difference of 3 volts. Now, because we start from 0 volts, that means that if the difference between these two is 3 volts, this voltage is going to be 3 volts. So at 2.5 millimeters above the negative plate, V, the voltage, is going to be 3 volts. I told you there were earlier at the beginning that there was a simpler way of doing this, and that is just using ratios. Let me redo the diagram again. Here we have the diagram I used before, where we have 0 volts to 24 volts. And so we know it's 20 millimeter difference between them, so I'm just gonna, here's where we can kind of use ratios to help us. So because we're going from 0 to 24 volts, the electric field here is constant between the plates. And so we can use proportionality to help us. One of the things to note is, halfway between the plates, what's halfway between 0 and 24? Well, that just turns out to be 12 volts. And by the way, this can only be done with the parallel plates because the electric field is a constant value between the plates. If electric field wasn't constant, then we wouldn't be able to do it like this, with this much sort of using symmetry and proportionality to do it. So it's only because the electric field is constant. So with 0 and 12 volts being right in the middle, that's right where D is 10 millimeters above. So What about halfway between 0 and 12 volts? Why, that would just be 6 volts. And that would be at 5 millimeters. And I think you can see where I'm going with this, because if we're looking for 2.5 millimeters, that's halfway between 0 and 6 volts, and that would just be 3 volts, which is what we got when we went through all the mathematics of it. But anytime the field is constant, which is pretty much generally anytime we have parallel plates connected to a battery here, the voltage like this is going to be kind of proportional, and sometimes you can get away without doing all the fancy math by just looking at the ratios as we go through. Anyways, the answer is 3 volts. If you have any questions on this, please feel free to come and talk to me. Other than that, thank you for watching and have a great day.